we'll show you a little bit what happens. We'll pull this auger in the line again. Okay, the auger's in the line. You can't tell. Last time it tripped the line, this apparatus out and shut the line off. But based on soil conditions, sandy soil is a very high resistance to it. We've all found power lines laying on top of a sandy hill. They're still energized, and you can't tell. We have equipment that tells whether it's alive or not. You don't. So unless you hear different from us, that line's alive until we tell you different. So say you do decide to get out of that vehicle, or you go to push this auger out of the line. This ground lead here, when we take it off, it's just like us standing on the ground. And just watch kind of arc it'll draw when you do touch that auger. And then remember the wiener test, because it all kind of goes together here. You just about have to touch it before it'll draw an arc, but once you draw that arc to ground, you can sometimes take 10 feet before you can break it. A lot of people think too that if they're in a vehicle that's got rubber tires, they're protected. Well, high voltages will just hop across the rubber, and quite often that's where we really get in trouble, because they'll start your tires on fire. Okay, another little thing I want to talk about is called step potential. Now this auger's in the line. You got 14,000 volts going in the ground. But it doesn't go straight in the ground and stay there. It dissipates out, kind of like throwing a pond into a pebble, or a pebble into a pond. It kind of, the waves dissipate out. They get smaller as they get farther away from point of contact. Same thing here. It generally takes about 30 feet before all the voltage is dissipated. And as it's doing so, it's got something called step potential. You're standing here next to the vehicle. You got 14,000 volts going in the ground 3 feet away, which is the average step. You may have 10,000. Now you got 3,000 or 4,000 volts trying to go through your legs. So we tell you to stay in that vehicle. Wait till Sask Power comes. Keep everybody 30 feet away, which is outside of the step potential zone. But this piece of equipment doesn't trip out, so your vehicle starts on fire, the tires start on fire. Well, you're not going to stay in there and get burnt up. So we'll try to explain to you the best way to try and get out of there. So the vehicle's on fire. Oh, if you're in your tractor, your truck, what have you, damage has been done. If it's still capable of running, put the thing in gear and try to break contact. And another pole or two ripped down really doesn't matter when your life's in danger. But you're stuck, or the engine won't run, and you have to get out of there. So what we tell you to do is open the door, try to see where the line's making contact with whatever piece of equipment you're on. You don't want to get out and stick your head in the line. So you see where that is, and you get out on your running board, the ladder, your combine, or what have you, and you hold your hands in front of you like this. All that does is kind of put the center of gravity on the front part of you, because you're going to jump clear of that piece of equipment. You don't want to fall backwards. So take a jump, 3 or 4 feet, and land with both feet together. As long as your feet together, you don't have that 3-foot step potential, right? So keep your feet together, and then continue to hop. Most of us aren't really capable of that anymore, so just shuffle. We can do that pretty good. Shuffle along, both feet together and on the ground. As long as you're doing that, you don't have that 3-foot step potential, eh? So do that until you're about 30 feet away. And if you're still not sure, you can kind of slide your feet apart a bit, and if you don't feel any kind of tingle, you're probably out of the zone. Now once you're out of that zone, please hang around, keep anybody else from wandering into it until Sask Power can get there, ground the line, and tell you that everything's safe.